Okay, so during this video I'm going to be talking about muscle contraction, how it happens, the sliding filament theory and the types of contraction. So in order for a muscle contraction to have to take place, there must be a stimulus, for example a ball coming towards a goalie. The ball would be received by his sensory organs, which would be, for this example, his eyes. They are then transmitted to the brain via a sensory neuron. That makes up the peripheral nervous system. The brain makes a response and forms a motor neuron, which then travels down the spinal cord. The brain and spinal cord make up the central nervous system. Now, in that motor neuron, myelinated nerves allow for salutatory conduction. This means the impulse of the motor neuron hops over the myelin sheaths to travel along the nodes of Ranvier in the axon. This allows for a much quicker transition. Eventually, the impulse reaches the axon terminals, which attach to a muscle fibre. This forms a motor unit. Once it has reached the axon terminals, acetylcholine is released from fascicles in order to fill the synaptic cleft. This allows the impulse to enter the muscle fibre. Now the impulse travels down T tubules, which eventually reaches the sarcoplasmic reticulum, and that impulse triggers calcium release. During this process, a small amount of ATP is delivered to the myosin arms to charge them. The calcium removes troponin and tropomyosin from the active binding site. The active binding site is then free to bind to the myosin arms. It will then pull on the actin arms once it has binded to them, and it creates cross bridges. During this, more and more ATP is required from the body in order for contraction of the sarcomeres to take place. ATP gets recovered by the troponin and tropomyosin at the end of the contraction, so that's the active binding site after the contraction getting recoated in the troponin and tropomyosin. And that's how a muscle contraction takes place and forms the sliding filament theory. Back to this slide, sorry. This also shows you the structure of a sarcomere. So a sarcomere is a structural unit of a myofibril in striated muscle. It consists of a dark band and the nearer half of each adjacent pale band. Z-discs, which you can see here, divide sarcomeres, so their job's quite simple. The H-zone. The H-zone is the zone of the thick filaments that is not superimposed by the thin filaments. The I-band is just myosin. They overlap during contraction, which makes them smaller. An A-band is the dark band of muscle that corresponds to the thick myosin filaments. The thin filament is actin, and the thick filament is myosin. Now onto the contractions. There's multiple types of contraction. There's isotonic contraction, which breaks down into two different forms. Concentric contraction, which is this diagram here. So concentric contraction occurs when the muscle length shortens during contraction. For example, the biceps brachii during the upwards phase of a bicep curl, as you can see in this diagram. As the arm moves up, it's being pulled by the biceps brachii, hence it's shortening. Isotonic contraction in its eccentric form is when the muscle lengthens during contraction. For example, the triceps brachii during the upwards phase of a bicep curl. This is the antagonist in this, therefore it relaxes. Next is isometric contraction. This is when the length of the muscle does not change during contraction but still contracts nonetheless. For example, the rectus abdominis during a plank. And finally, isokinetic contraction is a contraction that results in a constant speed against a resistance. For example, an arm stroke during swimming. The water resistance allows the performer to maintain a constant speed. And that is the end of my video. Thank you.